Hello everyone, this is Lama Nayal. I will present the project I did with my team members in Metro Malls company. We conduct a Gage R&R study, SPC and process capability. Metro Mall is located in Minnesota, Rogers, and was founded in 1973. It produced many malls. Our project was conducted in the fuel cell department. When we will do any measurements, we need to have confidence that our measurement system is accurate and is suitable to do the measurement of any of our characteristic. Then we can use it to make NSPC charts and then to do the capability analysis. So the objective of the project was to perform a Gage R&R study in order to use it to give the SPC process analysis and also the capability analysis. So the scope of the project was to perform a Gage R&R study on monolith plates to measure its thickness after lamination process, make an SPC chart using XBAR and R charts, also conduct a process capability analysis, then to check the inherent repeatability of the measurement system. The methodology of the project was we choose the quality characteristic. As I said, it is the thickness of the monoliths after lamination process. The Gage R&R was conducted by choosing 10 items. Each item was measured by 3 operators, and each operator did the measurement for 3 times. We get at last 90 data. Then we choose a random 4 sets. Each set consists from 8 items. So at last we get 32 data. We use this data to do the SPC analysis and the process capability analysis. For the inherent repeatability, we choose 1 item and we measure it for 25 times. Minitab program was used to conduct all these analyses. As we conduct the Gage R&R study, we get this ANOVA chart or ANOVA table. We need to examine the p-value. So for the part number, the p-value is less than 0.05, and the null hypothesis was that parts has the same thickness or has the same mean. And in this case, we will reject this null hypothesis. And that's good because we need to have variation in parts to have a big range in the data. The other thing that is the operator, the null hypothesis was that the operators has no effect in the measurement system. In fact, the p-value of that is 0.236, which is more than 0.05. So we failed to reject this null hypothesis. The other null hypothesis was that there is the interaction between the operator and the parts has no effect on the measurement system, and in fact the p-value in this for that thing is 0.011, which is again less than 0.05. So we reject this hypothesis. For the Gage R&R, we can see that the total Gage R&R is 4.56, which is acceptable, and we can notice that the more variable, the more contribution is from part to part that contribute with 95.44 of the total Gage R&R, and this is very good because in any measurement system we don't want the variation to come from the repeatability of the readings or from the reproducibility. vice versa, we need to have the variation in any measurement system because of the part itself. That shows that the part itself has variation and are not the same. And this is very good. So we will for this test, we can say the Gage R&R is very good and it's acceptable. Now for this table, which is the study variation and the tolerance, we can see that study variation is 21.36, which is still acceptable. Less than 10% is desirable, but still 30% is still acceptable. And the study variation represents a standard deviation that comes from the measurement system. If we look to the tolerance, to the standard deviation on the tolerance, that represents a standard deviation coming from the measurement system as a percentage of the tolerance, and we can see that it is here in 2.48, which is also acceptable because it is less than 10%. So till now, all the criteria of the Gage R&R is acceptable. For the number of discrete gate keys, that means that how many gate keys can our system identify. Everything more than 5 is okay, and we have 6. So everything and even every point in the Gage R&R analysis, we can see that our measurement system is acceptable. So this is the graphs. The graphs shows clearly that the most variation is coming from part to part. That shows the mean of the data, and it shows how the data are plotted in that. This one shows the range data that shows that gives the mean and the range that the data are plotting in the range, and this one shows the mean and also the data. This one shows the many readings of each part by the operators. This chart shows the difference between the mean in each operator. We can see that Krishna and Lama, their mean is a little lower than Shipra. And this chart is showing the part number operator interaction. After we find that our measurement system is acceptable and we can depend on it, we conduct a statistical control chart. So it shows that our mean is 4.2 and our data is out of control because it's almost 4.8, almost 4.8. And it shows the range of our data, which is from 0 to 0.6. And in this case, we can say that our process is out of control. But in this case, we should shut the machine and adjust the process. But unfortunately, in our case, that cannot be done because this out of specification is coming from the previous process, which is the preform, and to adjust it, we need to adjust the whole design of the machine. That costs to $20,000. So for now we can't do it, but we are managing that in the next process, which is machining. So we bring back the thickness of the monolith to the desired specification. So we create a theoretical new mean, which is almost 4.8, and set another specification. Now our process is considered as under specific control, and also it gives the range again. And then we conduct a process capability. The eye chart showing the individual data, the moving range showing the difference between one data and the other. This is our process capability. We'll see it again. It clearly shows that our process is so tight. Standard deviation is small, but unfortunately it is shifted out of the specification limit, out of the upper control limit. So what we need to do is to keep the type of the process just to bring it back to its target. So as we see, the CP is 2.9, which is so good, but unfortunately the CPK is minus 0.6, is minus 0.60, which is less than the D classification, which is 1.1. This is for the within the set, and also the over capability, which means the whole data, like the within data is showing the CP and CPK for the 8 numbers, which is the set, and the red one shows the 32 data. Also the PP is good, 2.29, but the PPK is minus 0.48. So what we need to do is to keep the capability, this capability, which is so tight, just we need to bring them back to the target. For checking the repeatability, we take one part, measure it 25 times. The eye chart shows that our system failed in many times. In fact, there was some issue in the measurement equipment, so it was stuck many times, and it seems that it show this thing. So the result, the Gage R&R is acceptable, the process is out of control, the process is capable but out of control, the repeatability test was failed. So the conclusion, the equipment that MMT used to measure the thickness and of the monoliths is still suitable, so we keep using it, but we need to make a correction action to bring back our process back to its target. And the recommendation that we need to still use this measurement system, examine the repeatability test again, and we encourage the MMD company to do the adjustment of the design of the preform machine, because even they are now able to bring their process back to their specification, which was 4.2 by the machining machine, but in fact they are losing too much materials in that. That means also losing money. So we encourage them to do the adjustment for the preform machine, to have the product in specification from the lamination part, and save the money for the company. Thank you.